we're going to work together and figure them out. Okay? Everybody good? All right. Now, does anybody have a question before we start? So everybody is on this page, yes? Okay. So the first thing we got to look at is I got a swimming pool drawing here. I need to call your attention to that. What does that mean that I just highlighted? Does the pool look like this? Or is that just a representation of the pool? That is a representation of the pool, yes? It's not right. So the first thing I would do if I were you guys is I would have a look at that and make it make sense. This is 1 meter, yeah? This is 8 meters, yeah? So how far is just this part? 1. So how far is this little tiny part down here? 7. Even though it looks little. Does everybody understand that? Now, some people I've shown this to. I've got the drawing on the board. It's right there. Some people have seen it. So I'm going to go ahead and redraw this so it looks more like what it should be. 1, 7. Everybody cool? And then this is 15. Does everybody agree? Now, we want to fill the pool. Is that surface area or volume? Volume. Excellent. So this is a prism, isn't it? It's not a prism that we have a formula for, because it's not a rectangle prism or a triangle prism or anything like that, is it? But we do know from our data booklets that every prism is the volume is area of the base times the height, yes? Now, how many times have we talked about what base means? A lot, right? Base means a lot of things. It means the bottom. It's also the root word for basic. It's where we start from. Now, if this shape, which is a rectangle, yes, plus this triangle, and what does that shape do as you go backwards? It repeats over and over again, doesn't it? So this becomes the base. So if I know this area and I multiply it by the height, I'm going to get the volume, aren't I? Now the problem is, you guys are still locked into height being up and down, yes? But it isn't, is it? Because as soon as I lie down, my height is still feet to my head, yes? So the height, please, 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 you've got to let this go. If this pool, if I could turn it up like this, the height would be here, wouldn't it? And that height is across the pool. Does everybody understand? Okay. So if I can find this area, the blue and the purple, and I can multiply it by the height, which is 6, I'll know the volume, won't I? Does everybody understand that? Okay. So how do I find this area? Well, it's a rectangle and it's a triangle, right? How do I find the area of the rectangle? Of the rectangle is what? Yeah, because it's length times width, right? So how far is this part of the rectangle? 1. How far is this part of the rectangle? 15. So the area of the rectangle is 15. Is everybody okay with that? Okay. What about the triangle? What's the formula for area of a triangle? Base times height divided by 2, yeah? Now again, base times height. Here we are back at these words, right? They don't necessarily have to mean bottom and up and down. But base times height. The way we've drawn it, we can use it as bottom and up and down, can't we? Well, what is the base of this triangle? 15. What is the height of this triangle? 7. And then I divide the whole thing by 2 to get 52.5. So if the purple is 52.5 and the blue is 15, what do I need to do with those two numbers? Add them up. So that means that the whole front of my pool is 67.5, isn't it? Does everybody understand? Now, this shape that I'm coloring in red is 67.5. How many of them are there? 6. Because I go back, that shape repeats 6 times. So I take that and I do 67.5 times 6, and I get 405 meters cubed for the whole pool. Now, am I filling the pool to the brim? No. I'm only filling the pool 85%. 85% is 0.85, yes? You all know how to find percent. So I'm not filling it to 1, I'm filling it to 0.85, yes? So what do I do with 405 to get 85%? Times by 0.85. And I get 344.25. Now let's stop for a moment and look at this. Did we do any math that was weird? It's still area of base times the height. It's pretty easy numbers. Where was the trickery in this question? The prism, making you guys see that the base is not the bottom. It's this shape repeated. Is everyone okay with that? It's really hard to teach it to if you don't see it. But I don't know how else to show it. I've shown it with blocks a few times. It's been helpful. Right? And I can show you that again later if you're still having trouble with this. Everybody cool? Yeah? Okay. Let's move on to the next question. 1 liter equals 1,000 centimeters cubed. What number do I have here? I have meters cubed, don't I? But I know how to convert meters to centimeters, right? L? Oh, right, I forgot to do that. So, sorry. It'll take 1.8 meters per hour. So what do I have to do with that? I got to divide by 1.8. And it will take like 191 hours or something, right? 15? 191 hours, 15 minutes. Cool? Okay. Now this next question is a problem because once it really tells me who has been paying attention and who has just been plugging in numbers. Okay? Plugging in numbers works till grade 9. It's not going to work for you anymore. You actually have to think in math class now. So this question says, I know that 1 liter equals 1,000 centimeters cubed, yes? What do I have? Meters cubed. So I have to convert them, right? How do you convert meters to centimeters? You divide by 100, right? But I'm not converting just one dimension, am I? How many dimensions am I converting? 3. So I got to do 100 for the length, 100 for the width, and another 100 for the depth, right? So I am, no. Because each of those conversions is times 100, isn't it? So I need to do meters cubed to centimeters cubed. Meters to centimeters is times 100. That covers one dimension. I'm covering 3 dimensions, aren't I? So it has to be 100 times what? Another 100 times what? Another 100. And what does that equal? 1,000,000. Does everybody see that? Does everybody understand that? You can't convert it straight across because to measure volume, you need to measure 3 things. So you have to convert all 3 things. Get it? So now we know that 1 meter cubed equals 1,000,000 centimeters cubed. So what do I have to do to this meters to get it to centimeters? Divide. Meters to centimeters is divide. Meters to centimeters is times. So I must have to take my 344.25 and multiply it by what? 1,000,000. Now you can do that in your head because you know you move the decimal 1 space for every 0, right? But that's a pain. So you're just going to use your calculator. And what are you going to get for an answer? 344,250,000 centimeters cubed. Now, this question is asking for what? Is it asking for centimeters cubed or liters? Liters. 1,000 of them is 1. So what do I have to do? You know it's got to be multiply or divide, because it's always multiply or divide. Am I dividing by 1,000 or multiplying by 1,000 to go centimeters back to liters? I'm dividing. And when you divide by 1,000, how many zeros do you get rid of? 3. So it's 344,250 liters. Now, many of you should be saying to yourself, Mr. Myers, this is a stupid question. It's not a real-life question. Shut up. But it is a real-life question because all of you have swam in a pool. Somebody needs to be able to work this stuff out. And you will say to me, it's not going to be me. And I will say to you, because of course you can see the future. Right? You can guarantee me you are never going to need to know the volume of a swimming pool. Until you have kids and they're like, Dad, we want a pool. You better know how much water you're putting in it because they charge you for water. You also better know what happens when some punk kid next door stabs a pitchfork into your pool that you bought, the inflatable kind, and then it dumps water in your backyard and floods your basement. So have I. Crazy neighbor kid broke through my fence and destroyed my pool. Everybody understand? All right. Let's look at the next question. I want you guys to talk about that one by yourselves for a few moments. I'm going to pause the recording. It's a surface area and it's a volume unit, yes? What am I talking? Yes. Of course you can. Why wouldn't you? Schmars, I don't know why I'm not good at math. You guys know that you guys think I don't do this, but I have a list in my head of who asks and how often they ask. And when you come back to me after the first test and wonder why you're not getting good marks, and I say because you wasted 15 minutes of class getting water and going to the bathroom. No names mentioned, but I know who you are. I also know that bodies don't work that way because my plumbing is 4 times as old as yours and I don't need to piss as much as you guys do. Anyways, is this surface area or is it volume? I am filling the net. It's volume. So if I find the volume of the net and I divide by the volume of a puck, I'll know the answer, won't I? No. Why? You do have to do some subtraction. Yes, absolutely. So Brianna says, and that's her first reaction, I'm going to find the volume of the net, I'll find the volume of a puck, and then I'll subtract it, right? That makes perfect sense until you think about it for a sec. What's wrong with thinking about it that way, Cole? Pucks don't fit together perfectly, do they? They stand up perfectly, but they're a circle, aren't they? So what happens if I put a bunch of circles beside each other? What is happening right there? It's empty space, isn't it? And is there any way to fill that empty space with circles? No. So you can't do volume, can you? How wide is the net? Across the front. There's three numbers there. 1.83. It doesn't really matter which one you use. 1.83 meters, correct? Yeah? So the net goes across the ice 183 centimeters, doesn't it? How many pucks will fit across there? What math must you do to find out how many pucks you can fit there? Division, right? Division by what? How wide is a puck? 7.62, yes? So if I divide that by 7.62, will that tell me how many pucks will go across here? How many pucks is it? 24 exactly? 24.01. So you can't fit more than a 24th puck, can you? No, because it's 24.01. You'll fit 24. You won't fit the 25th. So I can make a row of 24 pucks, can't I? Everyone agree? Okay. How far back can I go? How far does the net go backwards? 1, which is 100 centimeters, yes? What do I have to divide that by to know how far back I can go? 7.62. So how many pucks can I go backwards? 30? 13? 13. So I can have 13 pucks going backwards, yes? Is that the bottom of my net? Is that the whole bottom? 24 pucks this way by 13 pucks this way. Just wait. Is that how many I can fit on the ice in my net? You say no, Emily. Why do you say no? That's the line of pucks across here. There's 24 of them. And there's 13 pucks backwards. Well, that is the floor of the net, right? Because I go 13 across, or 13 backwards and 24 across. Understand? Okay. Yep. And that'll tell you how many pucks fit on the ice, yes? How many pucks is it? How much? 312, right? Does everyone agree? So on the ice, in my net, I can have 312 pucks, yes? Now what's going to happen? What's the third dimension? We've done across the net, up, and there's 312 down there, and then I'm going to stack them up. How high can I stack them? 1.22 meters, which is how many centimeters? 122. What do I have to divide that by? Why is it 2.54? Why isn't it 7.62? 7.62 is across the puck. 2.54 up and down, yes? So how many pucks will fit up and down? 48. So as Brianna says, she recognizes I got 312 on the bottom, right? But I can fit 48 pucks upwards, yes? You got 312. Why did you divide 312 then? 312 is how many pucks are on the ground, right? Now I got to see how many pucks I can stack upwards. So I got to take 122 centimeters, the height of the net, right? And divide it into 2 centimeter chunks to see how many stacks I can build, right? And when I do that math, I find that I can put 48 pucks up, yes? Does everybody understand that? Okay. If I can fit 48 pucks up and down, that means this whole bottom, which is 312, is going to stack how many times high? 48 times. That's, the net is 1.22 meters tall, which is 122 centimeters. Now, I divide by the height of the puck, and I know I can get 48 of them upwards. So if the floor has 312, and I can stack 48 tall, what do I do with these two numbers? Multiply them. And what do I get? And that's how many pucks would fit in a net if you stacked them. Now that is a stupid math class question, because you would never do that in real life. Why did I give it to you? All of you knew that it had to do with volume, yes? Most of you, the reason I give this question is because it really illustrates that the volume of any prism is the base times the height. Right? Because I could put 312 pucks on the ground in the net. And then I can stack that 312 48 high. Got it? And of course, this will be on YouTube. You can go back and check it, but nobody will. Okay, next question. Again, we're going to look at this. Company produces 100,000 cans of soup per day. They need to put a label on the can of soup. Is that label volume or surface area? Surface area. What shape is a can of soup? Cylinder. So the surface area of a cylinder is what? 2 pi r squared plus 2 pi rh. Is there paper going on everything on the cylinder? Where does the paper go? Only on the side. Which one of those is the side? 2 pi r squared or 2 pi rh? Two pi rh is the side, right? So do I care about this? Nope. I only care about this, right? So 2 pi, what's r? 4.25. What's h? 12. So then I do that math, and what do I get? Don't do that. Leave it as pi. There's a reason. 2 times 4.25 times 12. What do you get? You can use your calculators. You should be using your calculators. This is practice. I don't know why I'm not hearing the sound of calculators clicking. 102. Thank you, F.A. Is there anybody that does not understand what I did there? Because if you're at this point, you don't understand what I did there, I should be seeing you in X blocks, lunches, and after schools. Is everyone okay with that? Okay. Now, that's one can, yes? How many cans do I make? 100,000, yeah? So what do I need to do with that number? Times 100,000. Now, L, could you get your decimal there if you want? Yeah, sure. Or you can do that times 100,000 and multiply that by pi. Whatever. I don't care what you do. So if you're going to do that with your calculator, you're going to find out what that is. Then you're going to multiply by 100,000. What's that going to give you? You should be practicing that on your calculator, because you guys need calculator practice. Let's check. 102. Oops. 102 pi times 100,000. 32,044,245. What was it? 32,044,245. Right? Now, this right here, you already know how to find that. That's just on your calculator, 102 times pi, to go there. Everybody in the room should be able to get to that number. If you cannot get to that number, I will not make you publicly announce it right now, but you need to be taking care of yourself. If you cannot follow this line of thinking, you need to be here in your spare time. Or you need to be over in Miss Dosanjic's class in your spare time. Or you need to be down in Miss Molinelli's room in the help center in your spare time. Or you need to go find somebody else who knows how to do math in this building, which is every science teacher and every other math teacher, to help you get there. Okay? Also, you need to know why you can't get that answer. So let's look at our steps again. We know that's a cylinder. We know I only care about the side of the cylinder. Now let's pretend you don't understand that formula. You go to your data booklet, and you see right there, it even tells you the side of a cylinder is 2 pi RH. So let's pretend you don't understand it. You do know how to read, right? Because I only cared about the side. Everybody cool? I want to stop here because I'm going to make you do that for homework. But before you do that, we're going to get the measurements for the classroom. Okay? I'm not going to make you guess. So, I want to cover the walls. Does the walls include the floor? No. Do the walls include the ceiling? No. So I only care about the 4 walls. And I told you you could pretend that we didn't have a roof. So it's 4 walls, right? And I told you to pretend they were just plain rectangles, yes? You didn't have to worry about the cupboards. You didn't have to worry about this lump here. I said you could just consider it a basic room, right? So how are we going to measure these walls? What can we use to do so? We could use a tape measure. What else could we use? We could use meter sticks. What else could we use? Is there a way we could estimate it? How? How would you measure? How would you guys measure this distance from here to the window? Meters. Okay. Let's estimate it. What is about a meter? Okay. Is there something I can do that is about a meter? Take a step. Is that a meter? It's close enough, right? We're only estimating, aren't we? Because what does the question say? Estimate. Does the question say get out a ruler? The question says estimate. So that's 1 meter, right? And then I'm going to hit the counter, but I would get to the wall. It would be 9 meters, yes? So how wide is our room? 9 meters. Oops. 9 meters. What is the other measurement I need of this room now? I need this way, yes? How am I going to estimate it? I'm going to walk it again, right? Just for fun. Let's see how long it really is. 1, 2, 3, 4, 5, 6, 7, 7.5. Are we happy with that? Sure. Should we check and see if my steps are about a meter? Just for fun? Who's going to count the clicks for us? Me. Ready? Eight, and then this last little bit, pretty darn close to 9, right? Okay. So we had 7.5. Ah, my magic pen! It's so magic, I just made it appear. 7.5 meters. So, now the question becomes, do either of those measurements give me the area of a wall? No, what does that give me? It gives me the bottom of a wall and the bottom of a wall, doesn't it? Where else do I need to measure? Up and down. Now, I said we could just consider it. We don't have to measure up to there. So you guys got to use your head. Do we have in this room right now anything, let's call it just up to that beam? Okay? Do we have in this room anything that can measure up that high? Are you Spider-Man? If I stood on something, I might be able to do it. So this could do it, yeah? You want me to get up there? Do you have any idea how old I am? That would kill me. I tell you this because were any of you in the room when I did fall? No. I was climbing on desks over here. I was putting up Christmas lights or something. And the desk tipped. No, it was last year. And I fell like Parm between the desks. But get this. Move, move, move. I was such a ninja, I caught myself. Like that. I actually caught myself. It was wicked. You had to be there, though. Although, to be fair, all of my loving students couldn't ask if I was okay because they were all laughing too hard. Yeah. See, you can't even keep a straight face. You weren't even there. You're just thinking about it. It could have hurt me. My wife's got a teacher that works at her school who's like really old, like 60. No, my wife, apostrophe S. My wife's got a teacher at her school. No, that would be wives with a V. Anyways, this is not sister wives. I can't even imagine why anybody would care about that, though, man. One wife is hard enough to deal with. You want to have 7 wives? Go ahead, fill your boots. Oh, a tape measure!
No way. Oh, you have one. Is that in inches, though? Convert it, buddy.
Somebody got a tape measure. I can't reach down there, I'm old.
There I go.
Does it matter that it fell? No, because I'm holding it right here. So how long was it? 142 inches.
Nice. Okay, so what's that in meters?
Well, I guess we better convert it, right? Well, let's start converting. How do we convert feet to meters? 142 inches. So can I convert inches to meters? No, I can convert inches to centimeters. And then I can convert centimeters to meters, can't I? So what is it? 142 inches. What do I need first? Centimeters. So it's times 2.54, right? So what's that? $360? 360.68 centimeters. So can we call that 361 centimeters? Yes? Of course you can. How do I convert centimeters to meters? Then I divide by 100, yes? So how tall is the room? 3.61 meters. Now do I have all the numbers I need to find the walls? How? 2 of the walls are what? 2 of the walls are what measurement? 9 by 3.61. And what are the other 2 walls? 7.5 by 3.61. And there's 2 of them, yeah? So that's going to give me the area, right? What am I going to do with those 2 numbers? Add them up. So what is the walls of our room are what? Oh, I forgot I was going to make this homework, wasn't I? Oh, well. Screw it. You're not the boss of me. I want all of them. What's the whole area? So one of them was 64.98? So let's call that 65 because it doesn't matter which. And what's the other one? 54.15. So let's call it 54, right? 119 meters squared, right? 119 meters squared. How much paper have I used? What's my paper measured in? Centimeters squared. So I got to convert it, don't I? 1 meter squared. How much is centimeters squared? How much is meters to centimeters once? 100. Am I counting 1 or 2? So it's 100 times 100, right? So it's 10,000, yeah? So 1 meter is 10,000 centimeters squared, right? So what do I do with this number to get to meters? Multiply or divide? Divide. Because meters are bigger than centimeters, right? So the number has to end up smaller. So this, if I divide by 10,000, is going to get me my meters, yeah? What is it? $320.4 meters squared. So the soup factory uses that much paper in a day. Our entire room is only that big. Right? So we could cover our whole wall, all the walls in our room, up to that beam, how many times? 1, 2, 3, 4, 5. Oh, it's only 4. Yeah, 3,204. Sorry, I counted too many. 26 times. That's a good use of paper. Thank goodness we're cutting down the things that make ourselves oxygen to know that our soup has chunkies. That's why I don't watch the show Food Factory, because they're so proud of how much flour they use in a day to make Twinkies. It's enough flour to feed the whole world. But fortunately, we have Twinkies. Are they? Are they? There's no better use for those ingredients? Okay. "15 more minutes. There will be no homework tonight, of course, because I want you to study for your quiz. Last question today. Bicycle at the museum. Large front wheel, small rear wheel. Front wheel is 52, rear wheel is 18 inches. How far do I travel if I turn that front wheel around once? What measurement of that wheel do I need? And what do we call that, Emma? Circumference. Do we have a way to find the circumference? 2 pi r. Circumference equals 2 pi r. Well, it also equals pi d, because 2 r's is a d, right? Do I know the d? So circumference is 52 pi, right? I want that answer in feet and inches. Well, can I convert 52 pi to feet and inches? I can't convert pi, can I? I got to actually figure out what this is, don't I? Yeah, what's 52 pi? 163.36 inches, right? I want feet and inches. So what do I do with that to get to feet? Divide by 12. And that gets me 13 and a bit, yeah? It gets me 13 point, I think it's 7. Okay, so 0.61. 0.61 of a foot. That's not inches, is it? What do I got to do with 0.61? Times or divide by 12? Times. So it's 13 feet and how many inches? 0.61 times 12 to get, should be about 7 inches. 13 feet, 7 inches. Now I need that in meters and centimeters. How do I do that? Why would you do 52 pi? You've got your feet and inches right here. Just convert that to centimeters. So you've got 13.61 feet, and you need that in centimeters. Or meters, right? 1 foot is 0.3048, right? And I want that, so 0.3048. Multiply by 0.3048 to get what? 4.15 meters, but I want meters and centimeters. So it's 4 meters and how many centimeters? 15. So if that's one turn of the wheel, I want to go 1,000 meters, don't I? Yeah. A kilometer is 1,000 meters, right? So I take 1,000 and I divide it by what? 4.15 to find out how many times I got to pedal that damn thing. How many times is it? 240. So 241, right? I've often said if people really cared about being extreme on the X Games, they would do the half pipe with one of these bikes. That would be badass. Oh, great, you can do the half pipe with a fully suspensioned mountain bike. Oh, awesome. And then, of course, the smaller one, you got to do it all again. Your homework tonight is to do C. Or you could finish it right now in the 10 minutes before. I thought this class went to 1:30. Stupid X block. All right, no homework tonight. Be ready for your quiz tomorrow. All the questions we did today were way harder than what's going to be on your quiz.
Awesome.
So if you could follow this even a little, you're ready for your quiz. Have good days.